Hello, everyone. I am Wang Junliang from Scantech. I am delighted to share my thoughts on handheld 3D scanners with you. Today, the topic is 3D laser scanning technology empowers high-end equipment manufacturing. The presentation consists of 4 parts: castings and forgings inspection, mold manufacturing, product maintenance and aftermarket. These are also the main phases of industrial manufacturing. First, let's talk about how 3D scanners are applied in casting and forging. There is a long history of casting and forging, which can date back to thousands of years ago. Here, I will discuss 4 aspects of the inspection. Inspection of the cast and forged parts. Allowance analysis. Delivering the inspection results to the manufacturing equipment. The last is the optimization of the design of casting mold and forged die. As you can see, there is a picture of a wood model being scanned. The casting and forging molds are usually huge. I used to see a mold longer than 10 meters. It is challenging to inspect these large-scale molds. We recommend handheld 3D scanners for measuring. From the picture, we can see the technician was using a 3D scanner to measure the part. The mold is large, and it is hard to transport it to a measuring lab. With a 3D scanner, we conducted an on-site 3D scanning of it and obtained its point clouds. We then compared the data with a nominal CAD model and obtained a color map. The picture next to the wood mold is a color map. The green areas in the map mean deviations are within the desired range. The warm colors such as yellow and red and cool colors such as blue represent that deviations are outside the desired range. It is very convenient to identify these deviations to correct these molds. The molds come in different types: lost foam mold, wood mold, sand core mold and metal mold. 3D scanning suits well for these molds. Now, I'll show you some examples of how 3D scanning is used in mold inspection. Allowance analysis is the basis of the measurement of the cast and forged parts. When a forged part is manufactured, we should identify if there are sufficient or insufficient allowances on the pre-machined surfaces. Then, we need to check whether there is a uniform allowance distribution on non-machined surfaces. The key to precision machining is to adjust the coordinate system of the blank. In some cases, the blank can't be precisely machined with traditional ways. However, with 3D scanning, we can inspect it more accurately to get the change to adjust its coordinate system and machine it. How to machine the blank? We need to obtain the datum for the tool setting. I've listed a few of them here. Traditional line drawing. Technicians draw lines on the cast part, and the lines serve as a datum. The machining center then uses these lines to machine the part. Second, auxiliary tooling. Then, the robot-assisted method. The robot markers the part and delivers the information to the manufacturing centers. Another way is to align the scanned data with the equipment of machining centers. Adjust them to the same coordinate system so that the blank can be applied to the center directly. Delivering the inspection results to a center for machining is one of the hot topics in the industry. A large number of companies have devoted themselves in researching it. We have done a lot of researches on this and completed a lot of projects. If you're interested in this, you are welcome to talk it with us. Now, let's take a closer look at the casting and forging measurement characteristics. The first feature is large size. The second is curve measurement, and the last is datum for tool setting. So let's look at 2 cases. The first is the inspection of a large-scale wind power hub with curved surfaces. The ordinary 3D scanner aligns scans with markers. When it comes to 3D scanning this huge part, alignment by the marker is insufficient to obtain precise results. Its alignment errors accumulate over the distance of measurement. There is a particular technique called photogrammetry, which suits well for wide-range measuring. It can take pictures from different angles with coded markers to obtain 3D coordinates. Scantech offers a composite 3D scanner that combines scanning with built-in photogrammetry. The 3D scanner features 2 light sources, blue lasers and infrared lasers. When 3D scanning a huge boss wheel, we can use an infrared laser for rapid scanning. The second case is a mold that features deep grooves. 3D scanners project lasers onto the surface of a part, and its two cameras is used to capture lasers reflected. These two cameras have to see lasers at the same time. The camera distance of ordinary 3D scanners is relatively long and it is hard for them to capture details in grooves. We have a compact 3D scanner SimScan that is specially designed for it. The distance between its two cameras is much shorter, and the angle between the two cameras is relatively small, making it convenient for scanning deep grooves. Now, let's move to the second part, mold manufacturing. Mold is known as the mother of industry. It is a piece of important equipment in product manufacturing. A part that is newly cast will be sent to the machining center. The first task is the inspection of the rough part. We need to check its allowance. Its allowance may be sufficient for machining, but it may be non-uniform over the surface. There may be 20 mm allowances on one area and 2 mm allowances on another area. If we refer to a CAD model to set the machining program, we may face the challenge that the machine fails to eliminate the metal layers thinner than preset parameters. Therefore, we waste time processing. 3D scanners can obtain the accurate data on the blank and adjust the machining equipment by setting the program precisely. The processing path can be optimized in this way and increase machining efficiency. What else can we do? We can scan the mold machined and compare it to the CAD model to generate a report. The color map report can tell deviations intuitively. Green means qualification and red means disqualification. We can even get the specific values of deviations. Here is another example, which is assembling analysis. When the mold is manufactured, we must check whether the punch matches the die by assembling them. Check the interference or gap. Our 3D scanner can scan the die and punch fully and virtually assemble them on the computer to analyze it quickly. It's also a meaningful way to improve efficiency. The in-service molds are subject to wear and tear. So, we need to repair them. Our 3D scanners can scan the mold and compare it to the original model to identify areas to be repaired precisely. During the repair, there are many versions of changes. We can record these changes digitally by scanning parts and storing them digitally. It is very convenient. Next, we'll talk about manufacturing. 3D scanners are widely used in this industry. Let's take the automobile industry as an example and look at the process of producing automobile. For example, the assembly of the engine stamping parts and the sub-assembly. There are interior and exterior piping, lights, tires, boss wheel, seats, and glasses. As long as the dimension is involved, 3D scanner is needed. We can use 3D scanners to analyze the dimensions. Besides the manufacturing, another application is product maintenance and aftermarket. The maintenance part of the product is a process of remanufacturing. It is an emerging industry. Product maintenance includes product repair and remanufacturing. The remanufacturing uses technical methods to repair and transform waste products based on the original sector. The picture on the left is of a broken-down engineering machine, and some of its shafts were broken. Or we can say the shaft was deformed and required repair. There is no drawing available, so we need to scan it first. After analysis, we can provide guidance for the remanufacturing. The picture on the right is the scanning and analysis of a part for repair. Remanufacturing industry is still in its infancy, whose development can be accelerated with 3D scanners. Another application of the product aftermarket is customization. Customization is proliferating as the living standard improves. For example, caravan customization, pipe customization, and paint protection film. Our 3D scanners can obtain the dimensions of parts and conduct various tasks. Therefore, we can be confident in saying that 3D scanners can be widely applied for customization. And that brings us to an end. Thank you so much for your interest and attention.
Hello everyone, welcome to Scantech live streaming. I'm Harris from the Innovative Applications Department. Today, My topic is how to utilize 3D digitization technology to empower 3D printing. Scantech is one of the earliest high-tech companies starting to research and develop handheld 3D visual measurement devices worldwide. Our product line ranges from metrology-grade online and offline equipment to consumer-grade color 3D scanners. Scantech's 3D scanners are widely used for metrology in industries such as aerospace, automotive/rail transportation, machinery manufacturing, and so on. Besides that, we are working hard to improve our in-house 3D digitization technology. Combining 3D scanning and 3D printing is one of our core research areas. Then, I'll introduce you to 9 aspects of 3D digitization technology, how we utilize 3D digitization technology to empower the 3D printing industry. The first aspect, quality builds the future. 3D printing requires high-end tech and strict quality control. As long as there's product manufacturing, quality inspection is required. Here, at Scantech, we offer mature solutions for automated batch inspections. The industrial-grade laser 3D scanner we use has a maximum accuracy of 0.025 mm, which can meet the inspection requirements for most 3D printed parts. As we can see in the video, we can automatically generate a color map by scanning a 3D printed part with a 3D laser scanner and compare it with the original CAD model. In this way, we can tell if it is qualified or not at a glance. Besides, we can preset the comparison templates according to the inspection requirements to inspect items such as section deviation, center distance, contour, flatness, center coordinates, etc. Each part is automatically detected one by one according to the templates with automatically generated inspection report. This fast and comprehensive inspection method can be used in 2 aspects. One is to scan the finished 3D printed parts, compare them with the standard drawings, analyze the quality of 3D printed parts, evaluate the stability of the 3D printing and generate an inspection report. It ensures end users to provide high-quality 3D printed products. The other one is to use it to detect and compare different parts in the same batch or different batches, analyze the stability of 3D printers, and assist in the research and development of 3D printers with more stable production performance. We have successfully implemented this high-precision detection method in additive manufacturing technologies such as SLA 3D printing, wax 3D printing, metal 3D printing, and nylon 3D printing. Leading companies in 3D printing in China including Shanghai TPM 3D, Shanghai UnionTech, Beijing Longyuan AFS, have used our 3D laser scanners for daily production inspection or supplying our products to their customers, providing complete product delivery solutions. The second aspect is reverse design and smart restoration. One of our partners adopts 3D laser scanning technology to offer customers smart laser automatic repair solutions. This video demonstrates how to obtain 3D data of unrepaired parts by a 3D laser scanner, reversely acquire high-precision 3D models of the damaged parts by third-party design software, and automatically restore the parts by programming and path planning. The integration of the 2 technologies can help the manufacturing industry perform better. The third, medical rehabilitation. In the medical field, customized braces designed for the patient's pathological characteristics is required for treatment because of differences between patients and the complex structure of the human body. The emerging 3D technology, due to its features of custom-made and high precision, can easily solve the contradiction between the need for customization and the scale of production. The combination of 3D scanning and 3D printing technology can better help doctors achieve personalized and precise treatment for the benefit of patients. Let's take a look at the first case study, spinal orthopedics. One of our partners, Shanghai TPM 3D, customized spinal orthopedic braces for patients through iReal 3D non-contact scanning and nylon 3D printing technology. It takes less time to produce a customized brace which is more lightweight and breathable. Also, the brace is waterproof and antibacterial, suitable for long-term wearing. Compared to plaster brace, it is more comfortable to wear this brace without compromising the orthopedic effect. The second case is 3D printing fixation aid for tumor radiotherapy. Doctors from the first affiliated hospital of Zhejiang University School of Medicine used an iReal 3D scanner to obtain the data of patients' heads or chests. They 3D printed a fixation aid that fits the body part, which can immobilize the positioning mask better during radiotherapy. Therefore, the mask will not move or slip accidentally and help the patient acquire precise treatment. The third case is helmet orthopedics for babies. In the first 18 months after birth, the baby's head is soft and easy to deform on the pressure surface. Inappropriate sleeping positions may result in a plagiocephaly, a brachycephalic, or a navicular head. The doctor can safely collect the 3D data of the baby's head using the iReal 2 ES LED off mode. Then, he can design a suitable helmet according to the baby's head shape, and then use the FDM 3D printing technology or nylon 3D printing technology to produce the helmet. In this way, the baby can get the treatment safely under the protection of the customized helmet. The fourth case is a 3D printed rehabilitation aid injured leg. This case is from Donghua Hospital, affiliated with Zhongshan University. The patient suffered a ruptured Achilles tendon while playing basketball. Before the treatment was finished, the doctor went to the 3D Printing and Intelligent Manufacturing Research Center at the Dongguan University of Technology to test whether 3D printing a brace could help the patient's recovery and achieve a better result. By 3D scanning with the iReal 2E to obtain the data of the injured part of the patient, and then design and nylon 3D printing to make a personalized protective brace, it solves the troubles of airtightness, itching, and heaviness of the traditional plaster, and makes the later rehabilitation process more comfortable. The fifth case is the 3D printed customized prosthetic sockets. The doctor 3D scanned the patient's a disabled body part and the entire conventional prosthesis, and then simulated and assembled the two sets of data. He analyzed the still and dynamic stress range of the injured part and the line of gravity of the lower limb through finite element method software. After the treatment plan is made, the prosthetic socket is printed with a 3D printer to provide patients with a more scientific and personalized treatment and rehabilitation plan. The sixth case is the auxiliary treatment and analysis of ear injury and disability. This case comes from one of our customers, Hunan Plastic Surgery and Beauty Hospital. They SSE iReal 2E to scan and obtain 3D data of the patient's healthy ear, flip the scanned data horizontally, and 3D print a replica of the scanned ear. During the procedure, an orthopedic surgeon will craft the rib cartilage into the shape of the ear for the implant. In addition, doctors can also calculate the volume and surface area of the ear defect through the 3D model for better diagnosis and analysis. 3D printing technology allows users to produce products with unlimited quantities and high flexibility, and it supports customization. Its combination with 3D scanning technology can meet the individualized and precise medical needs in the medical field. Next, let us look forward to more exciting 3D scanning and 3D printing technology applications in the medical industry. The fourth aspect, art and design. In art and design, 3D scanning technology can help designers obtain the prototype data for engraving. Then, through 3D printing, it can proceed to mass production or derivative production. The combination of these two technologies has a wide range of applications in this field. For example, we cooperated with Shanghai Union Tech to jointly help Lu Renjie recreate an ancient Chinese mythological world, classic of mountains and seas. Since the clay sculpture is not easy to preserve for a long time, to ensure a better exhibition effect, we use 3D scanning and 3D printing to help create 809 exquisite exhibits. We overcame the challenges posed by traditional methods and help our customer to vividly present the fantasy world of the artwork. What is more, the data obtained by the high-precision laser scanner can be used for multi-process manufacturing, such as engraving, CNC, etc., and then according to different requirements, the corresponding process can be selected to produce derivative works of different sizes, which can be strong support for the IP of the classic of mountains and seas in the form of multiple business conditions. In addition, Zhu Bingren, the National Master of Bronze Sculpture Arts and Crafts in China, also chose 3D scanning and 3D printing technology to improve the research and development efficiency of copper art design. We also participated in the 3D digitization project of the Taoyuan Museum of Art in Changde, Hunan Province. The museum's treasure is the root carving of a willow tree with a root age of more than 1,300 years. It is 15.8 meters long, 6.3 meters wide, and 3 meters high. Through 3D scanning technology to obtain an accurate 3D model, we can rescale the model, and make derivatives through 3D printing, so that the craftsmanship can be more widely spread. Designers can also obtain the original data of artworks through high-precision 3D laser scanning for innovative design, and produce derivatives so that craftsmanship can be passed on more widely. In this area, we have deep cooperation with one of the top domestic 3D design companies in China, Shanghai Zubranz. For example, during the renovation of the Shanghai Concert Hall in 2020, Zubranz completed a 3D digitization project with the help of Scantech 3D scanning technology, focusing on scanning the iconic hall entrance, corridor patterns, architectural decoration patterns, original lamps, etc., and developed a series of derivatives such as jewelry, coffee cups, and cultural and creative gift boxes. The picture shows a part of this 3D digitization project, based on the classical blue carved seat. Through 3D scanning and 3D printing technology, they developed a home away from home-like derivative gift sets for the Shanghai Concert Hall. Let's look at the 3D digitization project of the ancient buildings in Wulin. By performing fine scanning of building parts, data analysis, 3D printing, and coloring, Zubranz helped the development of cultural derivatives and the online digital display of ancient buildings, thereby helping the inheritance of the culture of southern Fujian province and the overseas Chinese culture. The 3D digitization of historical buildings and cultural preservation buildings has become the trend of the times. Scantech 3D scanning technology allows the scanned model to truly reflect the style of the building in a 1:1 ratio. At the same time, the texture of historical traces, such as naturally weathered surfaces, peeling paint and colors, will be relatively natural, which is difficult to achieve in the traditional photo modeling method. As one of the top 3D design companies in China, Zubranz will continue to use Scantech 3D digital technology to carry out innovative designs. Under the guidance of the design concept of everyday aesthetics, the ultimate beauty will be in full bloom in daily life. Let's move forward to the fifth aspect. Due to the complexity and uniqueness of human body structure, it usually takes 1 to 2 weeks for designers to start modeling from scratch. In this case, 3D scanning shows a huge advantage. With iReal 3D scanning, the complete data of a person can be obtained within 3 to 4 minutes. The scanned data can be used for 3D printing after post-processing. This method will fully improve the work efficiency of prototype design, allowing them to focus more on creativity and design. In the case of the 3D scene of Su Dongpa harnessing the West Lake, the staff dressed in contemporary costumes and changed various postures for rapid scanning, which greatly improved the modeling efficiency and made the character models of the miniature scene more realistic. Also, you can 3D print a unique statue of yourself via this technology. If you are interested, you can consult Shanghai Union Tech. They will provide you with one-stop portrait customization services, including 3D scanning, design, 3D printing, polishing and coloring. Inspired by this, a Tai Chi association in Shanghai has customized a batch of unique trophies for the elderly, which were printed in full-color plaster, more realistic and beautiful. 3D human scanning can not only be used in medical rehabilitation and artistic portrait creation, but also can help the development of sports. During the preparations for the 2022 Beijing Winter Olympics, under the organization of the General Administration of Sports of China, the 3D Printing and Intelligent Manufacturing Research Center of Dongguan University of Technology, Associate Professor Li Nan's team, joined hands with Scantech to participate in the research project of helmet customization for athletes of the national bobsled team. The researchers first obtained the accurate 3D data of the athlete's head through the iReal 3D scanner, then customized the design according to the athlete's head shape and tactical characteristics, and then used 3D printing technology to print the final helmet liner. The helmet made in this way not only fits well but also has a lattice structure design, so that the 3D printing customized helmet not only has a better protective function but also is more lightweight, which effectively reduces the pressure on athletes and helps them speed faster. The unparalleled and exciting sporting competition is inseparable from the innovation of various industries in the 3D digitization field, and it is also a manifestation of China's rapid development in recent years and the improvement of its comprehensive national strength. China's winter sports are developing rapidly. To have a place in it, we have to use cutting-edge technology to inject new vitality into winter sports. We will continue to innovate our 3D technology for more competitive sports in the future. Now let's talk about the seventh application, car modification. Driven by young consumers, the automotive industry is accelerating into the era of personalization, and a huge, personalized automotive aftermarket has been derived. 3D scanning can help customize your car, rear modification, exhaust pipe modification, etc. You can accurately obtain the data of a part and customize it in the way you like. 3D scanning and 3D printing can help improve and you want by redesign. With the support of data and 3D printing technology, it is possible to quickly upgrade and optimize auto parts, which is faster and more convenient. The 3D reproduction of cultural relics is the eighth application. The Cambodia Institute of Intelligent Manufacturing and Scantech 3D carried out high-precision 3D scanning of the unearthed cultural relics at the Yecheng Museum in Handheld, Hebei, and archived the high-precision data to facilitate the later research and restoration of cultural relics. Through 3D printing technology, the 1:1 simulated cultural relics are copied for exhibition, which avoids irreparable damage to the authentic cultural relics during transportation and exhibition. Under the condition of ensuring the safety of the cultural relics, the general public can enjoy the exquisite cultural relics closely. Finally, it comes to our final direction, paleontological reproduction. In 2021, in Lufeng, Yunnan, Scantech participated in the whole process of digital collection and restoration of dinosaur fossils. Through high-precision tracking laser 3D scanning, the texture features and 3D data of newly unearthed dinosaur fossils were accurately obtained. Then the post-processing software was used for 3D model reconstruction, and then 3D printing to restore the dinosaur structure, and thus deducing the morphological evolution of Lufengosaurus 200 million years ago. Through 3D scanning, all the details can be truly restored, and even the tiny fossil cracks as well. At the same time, the latest high-strength photosensitive resin was used as the printing material, which was used later for scientific exhibitions. After the 3D scanning and 3D printing are completed, apart from being able to understand the appearance of the dinosaurs more directly based on the printed products, scientists can also obtain more information from the accurate data, do related research, and follow up on how the dinosaur lived, its relationship with contemporary dinosaurs and the living environment at that time, etc. Through 3D technology, the scientific research personnel found the key to the door of time and space and opened a unique science trip for us to explore the meaning of the information left by life on Earth 200 million years ago so that we can perceive the biodiversity. Scantech uses 3D digitization technology to empower 3D printing, intelligently create everything, so much more. We will continue to explore more applications and cooperate with more 3D printing companies to solve the challenges that neither of us can solve separately in the 3D digitization process, provide customers with more comprehensive 3D digitization solutions, help 3D printing technology be better applied in specific applications, and bring customers from all kinds of industries to enjoy the convenience and progress brought by 3D technology. 3D metrology technology enables intelligent manufacturing. We can control product quality together and build the future with quality. We can also create a better 3D world together. Okay, that's the end of our topic today. Thank you for listening, and look forward to working with you in the future in the 3D digital world. Let's experience the technological charm of 3D scanning and 3D printing together. See you next time.